Somewhere in a Tesla factory right now, a robot is learning. Not from code written by a programmer, from watching a human do the job. That sentence should make you stop for a second. Because if a machine can learn a task just by watching it done, then the question is no longer whether robots will enter the workforce. The question is how fast and how far beyond the factory floor they will go. This is not a story about science fiction. This is a story about what is already being built, tested, and quietly deployed, and why most people are still dramatically underestimating what comes next. Tesla's Optimus program has been in the headlines for years, usually followed by some version of the same reaction. Impressive demo, but not ready for prime time. And for a while, that reaction was fair. Elon Musk himself admitted in January of 2026 that no Optimus units were doing useful work in Tesla factories in any material way. That is a direct admission from the man who once promised thousands of units by 2025. So the skeptics had a point, but here is what the skeptics may be missing. The gap between demo and deployment in robotics is not a sign of failure. It is the normal shape of every exponential technology right before it stops being experimental and starts being everywhere. We saw it with electric vehicles. We saw it with touchscreens. We saw it with AI language models. First, they look like toys. Then they look like tools. Then they look like infrastructure. What Optimus can do today is genuinely limited by the standards of what a skilled human worker can do. Walking, basic object sorting, simple pick and place tasks, and teleoperation-assisted movements in structured environments. These are not the capabilities of a system ready to run an assembly line alone. But the direction of improvement matters more than the current snapshot. The hands on the second-generation design show a level of dexterity that did not exist 2 years ago. The learning pipeline is being fed by something no other robotics company has access to at the same scale. Billions of miles of visual data collected by Tesla vehicles and thousands of hours of factory recordings. That is a training advantage that cannot be easily replicated. And Tesla is not alone in this race. Figure AI has demonstrated manipulation capabilities that border on genuinely unsettling, including folding laundry and handling fragile objects with near-human precision under controlled conditions. Boston Dynamics brings decades of locomotion expertise that nobody else can match. Chinese manufacturers like Unitree and Xpeng are chasing lower-cost designs with the explicit goal of mass production at a scale that could undercut everyone. The competitive pressure in this space is intense, and that pressure accelerates the timeline for all of them. Here is the part most people are still not fully processing. The jobs most vulnerable to humanoid robots are not the exotic ones. They are not the specialized technical roles or the creative professions. They are the jobs that involve repetitive physical tasks in predictable environments. Warehouse picking, palletizing, basic assembly, logistics sorting, simple inspection work. These are jobs held by hundreds of millions of people globally. And they are exactly the kind of tasks that a robot capable of watching, learning, and repeating is designed to absorb first. Goldman Sachs and Morgan Stanley have both published long-range forecasts projecting market scenarios worth tens of billions by 2035 and potentially reaching $5 trillion by 2050 if adoption curves accelerate. Those numbers are projections, not guarantees. They depend on cost reductions, reliability improvements, and safety certifications that have not yet materialized at scale. But even a fraction of those scenarios represents a civilizational shift in how labor is organized. The honest version of this story includes the barriers. Battery life and power density remain serious constraints. The actuators that give robots human-like movement are still expensive and failure-prone. Perception in cluttered, unpredictable real-world environments is far harder than it looks in a polished demonstration video. And certifying a humanoid robot to work safely next to a human being involves a regulatory and liability landscape that barely exists yet. These are not minor obstacles. They are the reason this transition will take years, not months. But years is not never. And the question worth sitting with right now is not whether this technology is perfect today. The question is whether the direction of travel is clear. Because if you look at the trajectory of learning systems, actuator design, and manufacturing cost curves all moving simultaneously in the same direction, the picture that emerges is not one of incremental improvement. It starts to look like convergence. So what should you actually take away from all of this? Not panic, not dismissal. something more uncomfortable than either of those reactions. The honest takeaway is that the first wave of robotic labor replacement is closer than most people are prepared to acknowledge, that it will hit structured physical work first and hard, and that the industries and individuals who see it coming early will be in a very different position than those who are still waiting for the robots to stop looking like science fiction. The factory floor is just the beginning. What comes after that is a conversation we should already be having. If you want to understand the technologies reshaping work, industry, and the economy before they reshape your own situation, subscribe so you never miss what is coming next.